This is section 6.1, Law of Sines in Unit 4, Trigonometric Functions. In this section, we're going to study the law of sines, and the law of sines is used for an oblique triangle. An oblique triangle just means it doesn't have any right angles. This will work for triangles with right angles, but right triangle trigonometry does not. To find the law of sines, to create the law of sines, it's a simple ratio, and it's a pretty easy proof to show you, and it's in your textbook if you're interested in seeing it. In a normal year, I would show the whole proof. But to save time, we're just going to talk about what this ratio means. So if I were to draw a triangle, and this is just a generic triangle, and I need to label the sides and the angles. So the angles I'm going to label as uppercase letters. And then the sides are going to be the lowercase letters. So if this is angle A, opposite angle A is side A. This is angle B, opposite side B. Angle C, opposite is side C. And different textbooks might use different variables. This is what your textbook uses. So the ratio is going to be the sine of the angle to the side opposite that angle. And I typically write it as sine angle A over side A is proportional to sine of angle B over side B, which is also proportional to sine angle C over side C. And you could write this in the flipped version. I could have A over sine of angle A equals B over sine of angle B equals C over sine of angle C. It doesn't matter. This is just what I tend to use. Law of sines can be used for 3 different cases, and it's important that you understand which case that you're talking about, because we're also going to do law of cosines, but I do expect you to tell me which case is being used. So if you're given 2 angles and the side that's not between them, so let's just draw a generic triangle. If I were given 2 angles, say this angle here and this angle here, and then a side that's not between them. So it cannot be this side. It could be this side here, or it could be this side down here. It doesn't matter. This is going to be angle, angle, side. And this is why I'm going to require that when you do these problems, you draw and label the triangles. Okay, angle, side, angle, once again, is 2 angles. So it could be any 2 angles. Let's go ahead and use these 2 angles. Now the S is between the 2 A's, so the side has to be between those 2 angles. If it's in this configuration, it's angle, side, angle. And then the last one is side, side, angle. So you're given 2 sides. Let's say I'm given this side and this side. The angle cannot be the one that's between them. So it's not going to be this one. It's either going to be this one or this one. Let's go ahead and mark this one. This is side, side, angle. So you need to know which case that you're dealing with. Law of sines is complicated just because of this ambiguous case. What happens is the side, side, angle case may have 1 solution, 2 solutions, or no solutions. And I'll give examples of this during the live lesson. But if you're given 2 sides, so the way I have this one up here labeled, this is side B, this is side C, and this is angle B. So I would have sine of angle B over side B equals sine of angle C over side C. I would know this, I would know this, and I would know this. So I would need to solve for this. Well, the issue when solving for sine of the angle, sine of the angle is going to be positive in the first and second quadrant. And because of inverse trig, this is always going to give you the angle that's in the first quadrant. But sometimes that's not the solution. Sometimes it's the solution in the second quadrant. And I'll teach you how to figure that out. There's also times when maybe no triangle can be found with what the information you're given, and I'll explain that as well. This year we're not going to do any problems on area, but the area of the triangle can be found using this formula, area equals 1/2 base times the height. And in using the law of sines, you can manipulate that formula and come up with a different formula here. And there's 3 different formulas that go with this, depending on the size that you're looking at. And so we're not going to do that this year. We'll save that for another time.